alternative names for expected value are, let's see, so we can also call it mean, we can also call it a weighted average, we can also call it first movement. So these are all alternative names for expected value. So here the ideas are expected value, so here the ideas are expected value of a discrete random variable x is denoted by expected ex, or we can denote it by mu of x, right? So this is the notation that we're going to use for the expected value for discrete random variable x. So this is just some alternative names and notation. So now what's the context behind finding expected value of a random variable? Now we know that when we have a discrete random variable, we can completely characterize it using its PMF or CTF, right? Because PMF tells us all possible values in the probabilities, right? So it provides us everything we need to know about that random variable. But sometimes we might just want some partial information that tell us something, but not everything about the behavior of the random variable, such as expected value and variance, right? So basically, expected value and variance will not completely describe the discrete random variable like PMF or CTF will, but they will provide us some information, not everything, right? So it will provide us some, information, but will not completely characterize the random, right? So it will give us some partial information, right, about the discrete random variable. So this is the context. Now, before we actually go into how do we calculate expected value, we're going to look at the difference between simple average and expected value. Now, if I want to write the simple average of x, I'll write it as x bar. So now how do you find the simple average of x? So we'll just add all possible values of x and divide by total number of values of x. Because in simple average, you're essentially assigning equal weight to all probabilities. So here the key word is equal weight. Right? So when you're calculating the simple average of x, you just take all the possible values x can take, divide it by the total values of x, and you'll get the simple average, which is assuming equal weights for all values. Now, on the other hand, now let's talk about expected value. Now, in simple average, when you're calculating simple average of x, you will be assigning equal weight to each value. But when you're finding the expected value of x, you will give weight according to the importance of each value. Those values that have a greater chance to occur have a higher weight assigned, while those that are less likely to occur have a lower weight assigned. So unlike in simple average, we're not giving each weight equal value, but weights are given according to probability, right? So this is important. Right? In simple average, when you're calculating simple average, you're assigning equal weight to each value. When you're calculating expected value, you give weights based upon the probability of each value. So thus, this is now how we define expected value for random variable x. It's just a weighted average of the possible outcomes. So it's a weighted average of the possible outcomes of the random variable, where the weights for each outcome are assigned based on probability or likelihood of occurrence of that outcome. Right? So when we calculate simple average, so we're just assigning equal weights to each value. But when we calculate expected value, which we also call weighted average, mean, or first movement, what we're doing is we're assigning weights to each value based upon the probability of occurrence. So now let's see how do we actually go about calculating expected value. So how do we calculate expected value for discrete random variable? Let's say x1, x2, so on till xn are all the distinct possible values the discrete random variable x can take. So now when we want to find expected value of x, we know when we're calculating simple average, we're assigning equal weight to each values, but when we're calculating expected value, it's a weighted average of all possible outcomes. It's a weighted average of all. If we go back, it's a weighted average of the possible outcomes of the random variable, of the possible values of the random variable, where the values are assigned weights according to the probability, right? So here the weight I'm assigning to each, so I'm going to take a weighted average of all of its values, x1, x2, so on till xn. So I'm taking a weighted average of these values, and the weights are going to be assigned based on the probability of each value. Right? So the weight assigned to x1 is going to be probability of x1, weight assigned to x2 is probability of x2, weight assigned to xn is probability of xn. So when we're calculating expected value of x, it's just a weighted average of all the possible values of x, where the weights assigned to each value are based upon the probability. So this is the first possible value of x. And again, probability x is equal to x1 is the weight assigned to x1 based upon its probability. Similarly, this is the second possible value of x, and this is the weight assigned to that based on its probability, and so on. And now we can write this more concisely using summation notation, where xi here represents each value the random variable x will take. Right? When and probability x is equal to xi, that's corresponding probability. So this means that when I is equal to 1 plus, so this is x1, probability x is x1, then plus when I is 2, x2, probability x is x2. So we're writing this more concisely using summation notation. So now let's look at an example. How will we actually go about calculating? Now let's look at an example So in this example, so let's consider, so we have this random variable x which takes values 0, 1, 2, and 3. And let's say the probability that x is equal to each value is 1 by 8. Here it's 2 by 8. So this is the PMF of x given to us. So now I want to find expected value of x. What I'm going to do is I'm going to make a nice vertical table for this. So we know x takes values 0, 1, 2, and 3. And we know the probability that x is equal to each of these values in the PMF is given as 1 by 8, 2 by 8, 3 by 8, 2 by 8. Now, if we go back, when we want to find expected value, we essentially need to multiply each value with its respective weight, right? Because we're taking the weighted average of all the values where the weights assigned according to probability, right? So basically multiplying each value with its associated probability and then we're summing them up. So what we're going to do is we're going to create a new column for x probability x is equal to x, right? So we're going to multiply 0 into 1 by 8, which is 1 by 8. Then we're going to multiply this value of x with its corresponding probability. 1 into 2 by 8 is 2 by 8. Then we multiply 2 with its corresponding probability 3 by 8, which is 6 by 8. We multiply 3 with its corresponding probability 2 by 8, which is 6 by 8. Now I'm just going to sum this up. So this is summation, so written concisely, which is summing up x px of x. And this will turn out to be 15 by 8. So expected value of x, which you can also call the mean, the weighted average, the first moment, is summation over all x. So this is us writing it concisely, what we just saw over here, right? So we're just writing it concisely, this, right? So it's summation x px of x. So this is just 15 by 8, and in decimal form, this is just 1.875. Now, what if instead of expected value, we had taken simple average? If we had taken out simple average of x, if we had taken out, simple average of x, which is denoted by x bar, then if you had taken a simple average of x in this example, then this would simply be x bar is equal to, remember, how do you take simple average? You see all possible values that that random variable can take. You see all possible values x can take and divide it by the total number of values it has. So x can take values 0, 1, 2, and 3. So when you're taking simple average, we just add all the possible values it can take, which is 0 plus 1 plus 2 plus 3, and divide it by total number of values it has 4. Right, so here what we're essentially doing is we're just simply adding all possible values of x and dividing by total number of values of x. Right, and then this just turns out to be 6 by 4, which is 1.5. And this we can see is not equal to expected value of x, which is 1.875. So the idea is this, that in general, expected value and simple average are different. They can be same though in two situations where one, you have equal probability assigned to each value, because in this case you have equal weights, or when the distribution is symmetric. So here we've learned that expected value of a discrete random variable is the weighted average of all the possible values of the discrete random variable, where the weights are assigned based upon the probability of each value. Right? So this is different from simple average, where you have equal weight assigned to all values.